Hello students, let us continue chapter 14 Electric Current and its Effects. In the previous class, we discussed about the symbols of electric components such as electric cell, electric bulb, battery, etc. We also discussed about an electric circuit. Here we read that you might have noticed that a glowing electric bulb become warm, and we were asked that do you know why? So to find out the reason, let us discuss the next topic, heating effect of electric current. Activity 14.2. Take an electric cell, a bulb, a switch and connecting wires. Make an electric circuit as shown in figure 14.9. This activity has to be done using only one cell. Keep the switch in the off position. Does the bulb glow? Touch the bulb. Now move the electric switch to the on position and let the bulb glow for a minute or so. Again, touch the bulb. Do you feel any difference? After moving the switch back to the off position, touch the bulb again. For performing this activity, you will require an electric cell, a bulb, a switch and connecting wires. In figure 14.9, we are given a circuit diagram of electric circuit. We need to make an electric circuit just like this, and only one cell should be used for performing this activity. Try keeping the switch in the off position. We can observe that the bulb does not glow. When we touch the bulb, we can see that the bulb is not warm, that is, it is same as the room temperature. When the electric switch is moved to the on position, the bulb glows. Let the bulb glow for a couple of minutes and turn it off to touch the bulb again. We can feel the difference in temperatures. When we touched the bulb after it glowed for a minute, the bulb was a bit warm. Next, when the switch is moved back to the off position and when the bulb is touched again, the bulb is not warm. When electric current flows through electric bulb, a part of electrical energy gets converted into heat energy, and so the bulb on touching feels warm. This is due to heating effect of electric current. Activity 14.3. Make a circuit as shown in figure 14.10. Take about 10 cm long piece of nichrome wire and tie it between the nails. You can get nichrome wire from an electric repair shop, or you can use a piece of discarded coil of an electric heater. Touch the wire. Now switch on the current in the circuit by moving the switch to the on position. After a few seconds, touch the wire. Do not hold it for a long time. Switch off the current. Touch the wire again after a few minutes. For performing this activity, you will require a piece of nichrome wire, electric cell, electric switch, 2 nails and a piece of thermocol sheet. First of all, you need to take about 10 cm long piece of nichrome wire and you need to tie it between the 2 nails. These nails must be fixed at some distance on the thermocol sheet. Next, we need to make an electric circuit as it is shown in this figure 14.10. By connecting the 2 nails onto an electric cell through a switch using connecting wires, first of all you need to touch the wire when the switch is in the off position. Then you need to turn on the switch and pass current through the circuit. That is, when the switch is in the on position, the current passes through the circuit. After you have done this, wait for a few seconds and then you need to touch the wires, but be careful that you should not hold it for a long time. Just touch it for a few seconds. Then switch off the key and touch the wire again after few minutes. The nichrome wire remains at room temperature when the switch is off. The wire gets hot when the switch is on. That is, the nichrome wire gets hot when electric current passes through it. When electric current flows through a nichrome wire, a part of electric energy gets converted into the heat energy and hence the wire gets hot. Again, this is heating effect of electric current. Caution: do not keep the switch in the on position for a long time. Otherwise, the cell may become weak very quickly. So in this activity, we are using only one cell, and when the switch is kept in the on position for a long time, the cell will be used up and it may become weak very quickly. So this is the caution you need to follow while performing this activity. The wire gets hot when an electric current passes through it. This is the heating effect of the electric current. Can you think of any electrical appliance where the heating effect of the electric current is used? Make a list of such appliances. When an electric current passes through a wire, the wire gets heated up. This is known as the heating effect of electric current. So just like I told you, a part of the electrical energy gets converted into heat energy, and this is the reason why the wire gets hot. Appliances working on heating effect of electric current include electric heater, electric iron, electric stove, geysers, toasters, hair dryers, etc. You can also make a list of such appliances that make use of the heating effect of electric current. You might have seen an electric room heater or an electric heater used for cooking. All these contain a coil of wire. This coil of wire is called an element. You may have noticed that when these appliances are switched on, after connecting to the electric supply, their elements become red hot and give out heat. Here we can see the electric room heater. As you can see here, the coil is lighted up, that is, the coil is glowing. The electric room heater or an electric heater that is used for cooking contains a coil of wire, and this wire is called an element. When these appliances are switched on, after connecting them to the electric supply, you might have noticed that their elements become red hot and then they give out heat. So this is shown in this picture. As you can see, the coil over here, which is the element of this heater, is red hot, and after that it gives out heat. Bujo could not see element in an electric iron. Paheli told him that electric appliances such as immersion heaters, hot plates, irons, geysers, electric kettles, hair dryers have elements inside them. Have you ever seen the element of an appliance? Here in figure 14.11, we are given the element of an electric iron. I hope you all have must seen an iron, and this is not visible from the outside. यानी कि ये जो element है ये electric iron के अंदर है. So other appliances that contain elements inside them include immersion heaters, hot plates, irons, geysers, electric kettles, hair dryers. These are the appliances that have elements inside them. The amount of heat produced in a wire depends on its material, length and thickness. Thus, for different requirements, the wires of different materials and different lengths and thicknesses are used. The wires used for making electric circuits do not normally become hot. On the other hand, the elements of some electrical appliances become so hot that they are easily visible. The filament of an electric bulb gets heated to such a high temperature that it starts glowing. So here we are told that the heat that is produced in the wire depends upon three factors. Firstly, the material of the wire. Secondly, the length of the wire. And lastly, the thickness of the wire. So because of this, based on the requirements, different wires of varying materials, that is different materials, different lengths and different thicknesses are used in these appliances. The wires that are used for making electric circuits mostly do not become hot when the electric current is passed through them, while the elements that are used in electrical appliances become very hot. They become so hot that these wires are easily visible. For example, you can see the glowing wire of the filament of an electric bulb as it is shown in figure 14.2. So this is the filament of the electric bulb. It gets heated and because of high temperature, the wire starts glowing. An electric bulb is used for light, but it also gives heat. This is not desirable. This results in the wastage of electricity. This wastage can be reduced by using fluorescent tube lights in the place of the bulbs. Compact fluorescent lamps (CFLs) also reduce wastage and can be fixed in the ordinary bulb holders. However, before buying bulbs or tubes or CFLs, look for the ISI mark of the Bureau of Indian Standards. In fact, before buying any electrical appliance, look for this mark. The ISI mark ensures that the appliance is safe and wastage of energy is minimum. We all know the main purpose of an electric bulb. It is mostly used for light, but often these gives heat. They use electricity received by them in producing heat, but often there is no requirement of heat. So this consumption of electricity that is used in producing heat is wastage of electricity. That is why the lights that are available these days, which include fluorescent tube lights and CFLs as it is shown in figure 14.13. What is the full form of CFL? It is compact fluorescent lamps. These are better alternatives as they are efficient lighting sources. In order to save electricity and avoid wastage of electricity, we are advised to use electric appliances and gadgets which are electricity efficient. There is a standard mark assigned by the Bureau of Indian Standards that are given to the products. This mark is called the ISI mark. It ensures that the appliance is safe and also that there is no wastage of energy. That is, the wastage of energy is minimum. So you should look for the ISI mark every time before buying an electric appliance. If a large current passes through a wire, the wire may become so hot that it may even melt and break. But is it possible for a wire to melt and break? Let us check it out. We now know that the filament of an electric bulb gets heated and because of the high temperature, the wire starts glowing. But if the amount of current passing through the wire is large, the wire becomes very hot and because of this, there is even a possibility of the wire to melt and break. The answer to this question is yes. To understand this better, we will discuss activity 14.4 in the next class.